Okay, so I'm going to do the first question. I have a few of these just to remind you of how you would use the formulas. And guys, the nice thing about analytical geometry and always the analytical geometry section in an exam is they always have like the kind of stock standard questions. There's always a distance formula question where if you know how to apply that formula correctly, you can get those marks. There's always a midpoint formula question. There are, of course, questions that are also a little bit more complicated, but if you are able to just do the basics, you can get quite a few of those marks. Okay, so for 1A, they want us to find the distance between these 2 points. So it's 2, 3, and 4, 5. Now, whenever they're asking for the distance, you're going to use the distance formula. So you have your formula sheet, right? And you find the distance formula, and you are going to write it down. You don't have to, but I'm going to for the purpose of this. But guys, because it is on the formula sheet, you don't actually get a mark for it. Okay, so if you're running out of time, you don't have to waste time by writing it down. Just make sure that you can read it off of that formula sheet properly. And guys, please, if you write this formula down incorrectly, you get 0 straight away. So you have to be very careful when you're writing things down off of the formula sheet. Okay, even if you are rushing, I know that is an issue always, but please don't throw marks away on that. Okay, so what this means is we're going to take the x value of one of the points minus the x value of the other. It doesn't actually matter which one you start with. Right, you can start with either of them. So let's go with the first x value, which is 2, minus the second one, which is 4, and then you square it. Guys, if you do it the other way around, you'll get the same answer, because if we're taking 2 minus 4, what's that? 2 minus 4 is negative 2, and negative 2 squared is 4. If I went the other way around, right, if I said 4 minus 2, that's 2, and if I square that, I also get 4. Okay, so that's why I'm saying it doesn't actually matter which one you start with. So it's basically change in x's. One x value minus the other one, plus one y value, minus the other one. There we go, and you square that. You take your square root, and you type that into the calculator, and that is your answer. And if you feel brave enough, you can work it out in your head as well. These are actually easy values to work with. But you can also just use the calculator. 2 root 2 units. You can leave it like that. You don't have to do decimals. What's up?
It says correct to 2 decimals where necessary.
Oh, thank you. Okay. So then you would press SD, 2,83. So what did we learn from this? Read the instructions, please. Don't make my mistake. Okay, 2 decimals. Thank you for that, guys. That's an easy 2, 3 marks. Okay. Just applying the formula. There's nothing strange about it. You see distance, you use the formula. Okay. You can do the rest of number 1 if you want. I'm going to do 2A with you now. Sorry, guys, I am going quite quickly because I want to try and get through as much as possible. Okay, so just stop me if I'm going too fast. So in number 2, and in 2A specifically, they've given us these coordinates. 4, -1, and -1, 3. They are asking for the midpoint of the line segment with these endpoints. Right, so we have a line and we have these 2 points at the end of the line. They want to find the midpoint of this. Okay, so the midpoint formula is x value of the one point plus x value of the other point, and you then divide that by 2. So it's like what we did when we found the x value of the point of inflection, right? We added the 2 x values together and we divided that by 2. And then you're going to do the same thing with the y values. Again, you don't get a mark for writing the formula down, so you don't have to do it. So we're going to say the x value of the one point is 4. Now guys, the second x value is -1. So you can write 4 plus -1, but you can also just write 4 minus 1. Okay, that's the same thing. When you're adding -1, it's the same as minusing 1. And you would then divide that by 2. Next up, the 1y value, -1, plus the other y value, which is 3, and you then divide that by 2 as well. Equals. Now you would just work that out, right? 4 minus 1 is 3, and 3 over 2, you can just leave it as 3 over 2. You can write it as 1.5 or 1.5 if you want to, but 3 over 2 is also perfectly fine. Okay, you'll get full marks for that. The next one, negative 1 plus 3, that's 2. And when we divide 2 by 2, we're going to get 1. Okay, guys, you will get 2 marks for this. They usually give 1 mark for each coordinate. Okay, so a mark for the x, a mark for the y. Meaning it should take you about 2 minutes to do this. I think maybe if you are quick at this, it can take you less than 2 minutes, right? We need to try and get to the point where the easy questions, where we don't have to do a lot of thinking, where we do that as quickly as possible. Okay, but also not so quickly that we make silly mistakes. Okay, so we need to work on that. All right, any questions on number 2? Okay, 3a. Calculate the gradients of the lines passing through the following pairs of points. So we have negative 3, 2. And we have 1, 1. Okay, so they want the gradient. Remember, gradient is, I'm just going to write it over 2 lines now. y2 minus y1, or change in y if you want to write that. But again, you don't actually have to write the formula down. Okay, so we're going to say y minus y. So 2 minus 1. Guys, with these ones, if you swap x and y around, so if you do the x's at the top, you get 0. Okay, so make sure that you put the y's at the top, very important. So the one y value minus the other one. And now order is very important here. If you started with the first y value, you have to start with that same x value. Okay, so we're going to do negative 3, that x value, minus 1, minus the other x value. So we're going to put that over negative 3 minus 1. Okay, so I'm just going to write here, use same order at top and bottom. Okay, now you would just work that out. 2 minus 1 at the top, that's 1. And at the bottom we have negative 4. Okay, so the answer there is just negative 1/4. If you want to, you can type it into the calculator. It's not always easy numbers to work with. Sometimes they are a bit more complicated. So you can definitely use the calculator if it makes you feel more comfortable, right? Okay, number 4. Again, I'm just going to do 4A1. So number 4, there's a 4A and a 4B. So for 4A, they're saying determine the inclination of the lines with the following gradients. Inclination, angle of inclination. All right? So remember that formula was tan theta is equal to M. That formula was on the formula sheet. Okay. So we basically need to calculate theta. That's what they're asking us for. So we're going to apply this formula. M is always the gradient. So if they didn't give you the gradient, but they've given you information that will allow you to find the gradient, then you need to use the formula that we used up here to calculate the gradient. Okay, so it will just depend on the question. Did they give you the gradient? Then you just put it in there. Or must you calculate the gradient somehow? In this question, they have given us the gradient actually. They're telling us that the gradient is 3. Determine the inclination of the lines with the following gradients. For the first question, 3. So we're just going to say tan theta is equal to 3. And now to calculate theta, we are going to do shift tan of the number that we have, of that 3. So you can write down tan to the negative 1 of 3. And you're going to type that into the calculator. Shift tan 3, just like that. You're going to press equals. 71,57 degrees. Okay. I'm quickly going to do number 2 with you actually as well, because in number 2 we have a negative gradient and the method is slightly different if our gradient is negative. So again, they're asking for the inclination, so we're going to use the same formula. Tan theta is equal to the gradient, but for the second question the gradient is -2. Now when you have a negative gradient, guys, you are going to have to find a reference angle and then subtract that reference angle from 180. I don't know if you guys remember that from last year. Okay, so that is what you always have to do. You can't do shift tan of a negative number. You can, but your answer is going to be negative. Okay, and that's not what we want. If your gradient is negative, you are going to say RA, just like we did with, what section did we use reference angles for a lot? Trig equations, hey? Do you remember that? And when we calculated the reference angle in trig equations, we did the same method. We took tan shift or shift tan, so tan to the -1, and then instead of typing -2, we type +2. Right? We did the same thing in trig equations as well. You will then get an answer. We'll say shift tan of 2, and the answer is 63,43 degrees. But that is not theta, guys. That is our reference angle. To get theta, we are now going to have to say 180 minus 63,43 degrees. And we will get the answer of 116,57. Now guys, if the context of this question had nothing to do with angle of inclination, we would actually use the same method, right? If they said solve for theta in this equation, right? And your angle has to be between 0 and 180, because an angle of inclination is always between 0 and 180. We would also get our reference angle, and then we would say, in which quadrant will tan be negative? Tan negative. Not in quadrant 1, hey? Quadrant 2 and 4. Do you remember that we ignored quadrant 4 for tan, right? So this would be our quadrant 2 solution. Okay, the only thing that's different here is that we don't have a plus 180 in. Okay, because they've given it to us in a context of it's an angle of inclination. So we don't have to say plus 180 in. Right, I'm going to just skip past the rest of this page. I do want to do number 7 with you guys on Monday, so please circle that and remind me. I just don't want to use time now to draw that. So number 7, I would like to do those with you guys on Monday. Finding the fourth point of a parallelogram. Very common question, worth 2 marks. Okay, I just want to remind you of how to do that, but it is going to take some time just to draw that picture. All right, let's quickly go on to worksheet 2. Can I go? Are we ready? Okay, worksheet 2. Let me just see here. Okay, I'm going to do 1, B, and C. 1A is just a little bit too easy. I don't want to do that one. I'll do 1B and 1C. So in number 1, they're asking us to determine the equations of the circles. And for B, they've given us the center as -2, 3. Those are the coordinates of the center, and they are also telling us that the radius is 5. Okay, so now on our formula sheet, we know that the equation of a circle is x minus a squared plus y minus b squared equal to r squared. And a is always the x coordinate of the center. B is always the y coordinate of the center. And R is R, right? The radius is R. So we have all the information that we need, guys, to write down what the equation of this circle is. Okay, we don't actually have to do any calculations. We just need to remember that AB is the center, and then that is the radius there. Okay, so in our equation, x minus negative 2, what's that? X minus negative 2 is the same as x plus 2. X plus 2 squared. I'll just make a little note here. This is x minus negative 2. Plus y minus, what's the y value of the center? 3. Y minus 3 squared is equal to 25. You can write 5 squared, but then you have to go one step further and actually write 25. Okay, you're not allowed to leave it as 5 squared. Okay, 2 marks. 1 mark for each side of this equation. Okay, an easy 2 marks. All you had to do was put those 2 values in and square 5. Okay. In C, it's a little bit more complicated. Again, they have given us the center for 1. But now they have not told us what the radius is. They're telling us that this circle is passing through negative 2, 7. So unfortunately we can't just say r squared like we did in the previous question. We don't know what the radius is. Okay, we can fill in our left hand side though, right? Because we have the center. So we can say x minus, what is the x value of the center? 4. And then we square that. So the x value always goes in the x bracket, right? Plus y minus the y value, which is 1, squared, is equal to r squared. Now, what did I tell you yesterday and the day before and the day before and the day before? When you're finding the equation of any graph, sub in a point. They've given us this point for a reason, right? That's an x value, that's a y value. There's an x, there's a y. If I sub the x value in the place of x and the y value in the place of y, what can I get? R squared. Okay, so we are going to sub in negative 2, 7. When you are doing the working, you can just write the point down. I'm just writing the sub in part as a little note for you. So we're going to have x minus 4 is going to become negative 2 minus 4 squared. Plus y minus 1, the y value of this point is 7. So 7 minus 1 squared is equal to r squared. And now we can just work that out. Okay. This is going to give us negative 6 squared, which is 36. That's also 36. So 72. You can obviously use your calculator for that. Okay. R squared is equal to 72. Guys, am I going to square root that to get the radius? Did they ask for the radius? No. They asked for the equation, right? And in the equation, we have r squared. So in our equation, I'm going to put 72. Okay, it's a very common mistake to think, okay, r squared is 72, so I have to do the square root. That's only if they've asked you for the radius. Okay, which they haven't. They've asked for the equation. So therefore, x minus 4 squared plus y minus 1 squared is equal to 72. Yes?
If you use distance formula,
yeah, that's fine. So if you use the distance formula to calculate the length from the center to that point, but then you'll have to square it, because that will give you the square root of 72. You'll just have to square it then. Okay, any other questions, guys? Quickly, very important. We have 7 minutes. I want to do number 2. Let's do 2E. They've given us this equation, x squared plus 6x plus y squared minus 4y equal to 12. They are asking for the center and the radius. Now guys, we can only say what the center and the radius are, what the center coordinates are, and what the length of the radius is, if we have it written in this form, which clearly this equation is not. Okay, this is called standard form, in case you were wondering. We need a circle equation that's written in center radius equation form. Alright, so we need center radius equation form, which is this form, x minus a squared plus y minus b squared equal to r squared. So basically the form that's on the formula sheet, that is called center radius equation form. It's called that because we can see what the center is and what the radius is from there. So guys, we need to convert this equation so that it's written in this form. So I don't know if you can remember this from last year, but what we're going to do is we are going to complete the square for x and y. Does that ring a bell, guys? Complete the square for x and y. And completing the square is, I think, the thing that's done like on the first or second day of grade 11. So it's a long time ago. So I wouldn't blame you if you forgot how to do it. Okay, so let's quickly do it together. The first thing that you need to do is you need to group your x's and you need to group your y's, okay, which we do have. So group your x's and your y's. Just make sure that your x squared and your x are next to each other, and your y squared and your y, those are also next to each other. And you have to have your constant term on the other side. Right, constant. So it has to be in that form. Then what we're going to do is we are going to, and I'll say it and then I'll write it down, we're going to add b over 2 squared to both sides of the equation. Does that sound familiar? Okay. Add b over 2 squared, add b over 2 squared for x and y to both sides. Now guys, b is always the number in front of x or the number in front of y. So we have our x squared plus 6x plus, what is my b value? 6. So I'm going to say 6 over 2 squared, which you can write as 3 squared straight away if you want to. We're going to do the same thing for y. So we have y squared minus 4y plus, now guys, it doesn't matter whether your b value is positive or negative because you're going to square it anyway, right? And a positive number squared and a negative number squared, it's the same thing. So let's just ignore that minus. We're just looking for the number, and it's a 4, right? The number in front of y. So you're going to add 4 over 2 squared. Now you must do the same thing on the other side as well, guys. So we had a 12 on the other side, right? You must now add, sorry, I've run out of space there on the side. 6 over 2 is 3, right? And what is 3 squared? 9. Okay. What is 4 over 2? 2. And 2 squared is 4. Alright, so basically we're adding the same two numbers on both sides. How that helps us is that I'm now going to take these three terms and put it in a bracket squared. We're almost done, guys. So what I'm going to do is I'm going to say x. So you take the square root of that. You put it in your bracket. Oh dear, what happened there? You take your term there. I'll put arrows now. And this is a 3 squared, right? What's the square root of 3 squared, guys? 3. Thank you. That is what you do. Okay, so you take the x, you take that sign, and you take that number into the bracket, squared. Yes, I'll put it up. All right, next up, quickly, the last 3 terms here. That's going to form our second bracket. So we're going to take the square root of y squared, which is y. What sign is there? Minus. What is this again? 2 squared. What's the square root of 2 squared? 2 squared. Sorry, thank you for your patience. We're done now. Equals, you're going to work that out. 12 plus 9 is 21 plus 4, 25. Okay, that is in the right form. Guys, very quickly, last thing. The center, we can now read off from this form. If it's x plus 3 in my center, I'm going to have a negative 3. Good. And y minus 2, I'm going to have a positive 2. And what is the radius, guys? Remember, this is r squared. So 5. Good. Well done. Guys, I suggest that you work through the next one. If at home, 2f. Alright, just practice what we've just done. You're just going to have to move the 8x and the 2y over to the other side. Okay, I'm also going to post some other past paper questions on Classroom Now.